This is linear algebra. We're going to cover linearly independent. Okay. What is linearly independent? What is linearly independent? Okay. Here is the definition of linearly independence, linearly dependence. You have set of vector v1, v2, vp is linearly independent, meaning is this vector equation have trivial solution, which meaning is x1, x2, xp gonna be 0. That's what we call linearly independent, okay guys? The other way, this set of vector v1, v2, vp is same vector equation, but this one have non-trivial solution. Then vector set of vector gonna be linearly dependent. What is this metric equation we talk about? This meaning is there should be free variable. Okay, that case, this vector equation has non-trivial solution. Oh, okay. Let's give the example, guys. What do you mean by that? Linearly dependent, linearly independent. So very simply, like guys, first example is you guys understand the definition of linearly independent, linearly independent. Later on, we're gonna give some specific example, guys. Okay, let's practice this three vector v1, v2, v3. We talking about linearly independent, right? Or not. So what you have to do, guys, you have x1 v1 vector plus x2 v2 vector plus x3 v3 vector should be 0. We have solved this equation, so we have checked this equation, vector equation have non-trivial solution and trivial solution, okay? Another way you write it, this one is metric equation. A x gonna be 0, right? So A gonna be, guys, here v1 vector, v2 vector, v3 vector. Okay, so let's write down the augmented metric, guys. Let's go here, guys. If you remember correctly, this is coefficient. Here is coefficient. Here is constant term. That's the 0 vector. That's you write augmented metric first. So 1, negative 2, 3. That's the v1 vector. Negative 1, 0, 2. v2 vector. Here is 2, 1, 1. Here is 0, 0, 0. That's you write an augmented metric, right? I'm not going to go to detail of our operation to change this or the Angela form, guys. I'm going to speed up a little bit very quickly, guys. Here, you're going to need here R2 and R1 times 2 here, 2, negative 2, 4, 0. That's we have. What operation you did? 2R1 plus R2 go to R2. So let's write down the 1, negative 1, 2, 0, 0, 0. Here it's going to be 0, negative 2, 4, and 0. Right? Oh, no, 5, right? I'm sorry. Here is a 5. So another one is here, what do you need? The negative 3, R1, right there, negative 3, positive 3, and 6, and oh, negative 6 and 0. So what you did here, negative 3 R1 plus R3 go to R3. So this one is 0, 5, negative 5, and 0. Let's find the first one, right? So second one is gonna be, guys, I gonna make this one is a pivot. So here is third row. I wanna do third row divide by 5, which meaning is 1 over 5 R3 make R3. So this one is you're gonna do 1 over 5 R3. So you have 0, 1, negative 1, 0, right? So you have this one, 1, negative 1, 2, 0, 0, negative 2, 5, and 0, 0, 1, negative 1, 0. So simply like that. So this should be, guys, this guy should be pivot. So I'm gonna interchange R1, R3. That's how I'm gonna do it. So R2 gonna do R3, R going to R2, right? So you have 1, negative 1, 2, 0, 0, 1, negative 1, 0, 0, negative 2, 5, and 0. So we have two pivot. Here is pivot. Here is the second row pivot. You have this, it should be 0. So what you need right now, you need here 2R2 here. 0, 2, negative 2, 0. Does it make sense? So what operation you did? 2R2 plus R3 going to R3. So you have new one. 1, negative 1, 2, and 0. 0, 1, negative 1, 0. 0, 0, 3, and 0. Okay, let's check it. They have non-trivial solution or trivial solution. Let's go to third row. R3, row 3 is x3 gonna be 0, right? So second row, R2 gonna be x2 minus x3 gonna be 0. X2 gonna be x3, so this is 0. R1 is x1 minus x2 plus 2x3 equals 0. X1 is x2 minus 2x3 equals 0, right? So x gonna be 0, 0, 0. That's the 0 vector. So this one is a trivial solution. That's the linearly independent. So we don't have to check it. This, guys, look at this argument metric, guys. Without this, look at this argument metric, guys. There is a free variable. Here is x1. Here is x2. Column vector x3. First row have pivot 1. Second row have pivot. Third row have pivot. So this one doesn't have free variables, so you're gonna say linearly independent right away, guys. Okay. Okay. Let's go practice question, guys. Pause the video. You're gonna try to on your own, guys. Let's go to V1, V2, V3. I give the 3 factors. Let's check independent and dependent. If this is not independent, find the linear dependent relation between 3 variables, okay? Let's try it. First one, guys. How can check it? You have check x1, v1, x2, v2, x3, v3 gonna be 0. This is non-trivial solution or trivial solution. I want a mathematical matrix. 3, 1, negative 2, 4, 0, 1, 2, 2, negative 5. Here is a 0, 0, 0. So guys, you're gonna do row operation. So now you can do it, guys. So I'm gonna switch first and second row, guys. Just you already did. I assume you already did it. So R1, R2 interchange. You're gonna 1, 0, 2, 0, 3, 4, 2, 0, negative 2, 1, negative 5. So we're gonna have make this below the pivot 0 and 0. So what you need here, negative 3R1 plus R2 go to R2. So negative 3, 0, negative 6, and 0. So third row here, negative 3R1. Third row, 2R1 is going to 2, 0, 4, 0. So you have new one, 2R1 plus R3 going to R3. So you have this one, 1, 0, 2, 0, 4, negative 4, 0, 0, 0, 1, negative 1, zeros. Guys, make sense? Okay, look at the second law. I want to do second law gonna be times 1 over 4. So your operation is 1 over 4 R2 going to R2. So you have a new one. 1, 0, 2, 0, 1, negative 1, 0, 0, 0, 0, 1, negative 1. Here is a pivot. Here is a pivot. This should be 0, right? So what do you have to do here? You have negative 1 R2. 0, negative 1, 1, and 0. So that operation you need negative 1, negative 1 R2 plus R3. That's R3. So you have new one. 1, 0, 2, 0, 1, negative 1, 0, 0, 0, 0, 0, 0. Can you see that? Did you see free variable? So here is x1. here is pivot. Here is x2, here is pivot. Here is x3, there is no pivot. So x3 is free variable. So what are you going to say? You're going to say v1, v2, v3 is linearly dependent. So here is very interesting happen, guys. What is going to happen right there? What kind of relation between the here, guys? X3 is a free variable, so you're going to say X3 going to be S. So R2 going to be, row 2 going to say X2 minus X3 equals 0. X2 is X3, which meaning S. R1 going to be X1 plus 2X3 equals 0. X1 is negative 2X3. Guys, right there. So what do you have X vector? That's going to be X1 is negative 2S, X2 is S, X3 is S. Can you see that? That's going to be what happened here, guys. What happened? So you're going to see this one. That's going to be common vector is X. You find the vector negative 2, 1, and 1. That's the form of X3. So that's the linearly independent. So go back. This one is linear combination, linear dependent. Let's go to second equation. You see, number 2 is, so x1, v1 vector, x2, v2 vector, x3 is v3 vector is 0. Let's plug in back. What do you say? X1 is negative 2x3. That's the negative 2s, right? So negative 2s v1 vector plus, right? Here is x2 gonna be s v2 vector plus x3 gonna be s v3 vector equals 0, right? So let's just solve v3, guys. v3 or v1, whatever you want. Let's just solve the v3. s v3 equal 2s v1 minus s v2. So you say v3 gonna be 2v1 minus v2. So v3 vector is linear combination of v1 and v2.